Okay, this final exam review addendum is for the things that aren't included on the final exam review that I handed out. I think a few things that you should look at. So, question 1. Determine how many solutions these equations have. There are going to be three possibilities here. Either it's going to have one solution, which is what it is in most cases. It's going to have infinite number of solutions, which means that both sides are equal. And the last one is no solutions, and both sides will turn out to be impossible, not equal. So we'll start out with the first one. 6x plus 9 equals 3 times 2x minus 1 plus 12. Okay, so first thing we need to do is simplify both sides. The left side is already simplified, but the right side we have a distribution, and then I'll bet we have to add something together. So we'll copy this back down, and we'll take our 3, we'll distribute it over the 2x, which is 6x, and then 3 times negative 1 is negative 3, and that's plus 12. Okay, then we're going to combine like terms. We have 6x plus 9 equals 6x plus a negative 3 plus 12, which would be 9. Now we want to get, when I see this, I know that there's going to be infinite number of solutions. We have 6x plus 9 equals 6x plus 9. So no matter what you stick in for x, it's going to work. Anything will work. So any number. So I mean, and you can see that if we say subtract 9 from both sides. 6x plus 9 minus 9 equals 6x plus 9 minus 9. So that gives us 6x equaling 6x. And if you can't see it now, we'll divide both sides by 6, and we're going to get x equals x. So you can see that no matter what we stick in for x, it's going to work. Okay, so that's infinite solutions. Okay, we'll stick that one on the side, and we'll do the next one. We have 4x minus 1 equals 2x plus 3. Okay, so there's nothing that needs simplifying on either side. So we want to just get our x's all on the same side and our constants, our numbers, on the other side. So let's, what do you think? Add a negative 2x. Okay, so that makes the left side 4x minus 1 equals 3. Now let's get all our numbers on the right side by adding 1 plus 1 plus 1. And we have 4x equals 4. Divide by 4. Those cancel. We have x equals 1. And that is one solution. So we're done. Okay, stick that on the other side. So we have one left. We have 7 minus 5x equals 3 times 3 minus x minus 2x. Okay, again, we're going to simplify the right side. The left side, nothing we can do there, so we'll just copy that down. 7 minus 5x equals, okay, now they'll do the distribution. 3 times 3 is 9. So we're going to do our distribution. And, oops, distribute that one. So 3 times 3 is 9. 3 times negative x is a negative 3x. And we have minus 2x. Okay, so we still have some more simplifying on the right side. So we'll keep left. 7 minus 5x equals 9. And negative 3x plus a negative 2x is a negative 5x. Now, what we can do here is we could add 5x to both sides because we have negative 5x. 5x plus 5x. Okay, so that wipes out the 5x's and we have 7 equals 9. But of course we know the 7 does not equal 9. So nothing we stick in for x, nothing will work. So this is no solutions. So you see we have 3 different possibilities here. We have when both sides are equal, like here we get x equals x, or actually you can spot it right here when you have 6x plus 9 equals 6x plus 9. When you see that, when both sides are equal, then you know that infinite solutions. There will be infinite solutions. Then, this is what we're used to. We find that we get one solution, of course, it's one solution. And then the last one, when we realize that the two sides cannot be equal, then there's no solutions. Number 2 is not a problem. It's just I want you to notice something, and that is if we end up having something like x over 2, and we want to separate that 2 from the x, say we need it as a slope. Let's say that our equation was y equals x over 2 plus 3. 3 being our y-intercept. But what is our slope here? You know, it's not 2. So you need to know that x over 2 is the same as 1/2 x. For instance, x, if we were going to multiply 1/2 times x, we would go 1/2 times x. We would go 1/2 times x over 1, because x would be some kind of positive number. It wouldn't be a fraction. See, then you multiply the numerator times the numerator and we get x. Denominator times denominator, we get 2. See, so 1/2 x equals x over 2. So then I'm going to ask you, all right, what does x over 5 equal? Well, it equals 1/5 x, or x over 7 equal 1/7 x. Number 3. Another thing that drives me crazy is I'll see people taking something like this, x over x, and they'll put the answer as x. That is not right. That's not right. Don't do that. Or they'll go x cubed over x cubed, and they'll say, oh, well, x cubed divided by x cubed, that must be x. No, it's not. No, it's not. Any number, the same number on top as on the bottom, equals 1. It doesn't matter what it is. So if it's some complicated affair that looks like this, if it's the same thing on the top and the bottom, same thing in the numerator as in the denominator, it equals 1. And that's it. Same thing top, bottom, equals 1. Save yourself some trouble. Okay, number 4. I got this from one of our tests, I think. It's find the slope of the line and write the slope as a rate of change. Don't forget to attach the proper units. Units being, you know, dollars per mile or something. Okay, so the graph shows the total cost y in dollars of owning and operating a minivan, where x is the number of miles driven. So the slope, all lines show a rate of change. So in general, we're just talking about the change of y per the change in x. because it's because slope is the change of y over the change in x. That's what equals m, slope. Okay, so if we're talking about some kind of real world problem, we're talking about a comparison between one thing or another. And it's always the y over the x. In this case, it's dollars per mile. Dollars over miles would be dollars per mile. So to find the rate of change in this van problem, we need to find our slope. Now sometimes with these graphs, the line will cross through the interstices, the places where the graph crosses. You know, it'll cross right through where the lines cross, and you can just count the slope. But in this case, you can't. But they've given us 2 points. This one is 7,000 miles per 7,000 miles and at $5,250. And then this one is 3,000 miles at $2,250. I got mixed up there, but the x comes first and then the y. Okay, so we're going to calculate our rate of change. We'll use our formula, m equals y2 minus y1 over x2 minus x1. So we can have to decide which one's going to be our first point. It doesn't really matter which way we go. So let's make this our first point. Let's say that this is x1 and this is y1. This is x2 and this is y2. Okay, so y2 is 5250 and minus y1 is 2250, and that's over our x2, 7,000 minus 3,000. Okay, so the difference between 5,250 and 2,250 is 3,000. That's dollars. And the difference between 7,000 miles and 3,000 miles is 4,000 miles. See, so this is dollars, and this is miles. Okay, but we can reduce that. We divide 1,000 to the top and the bottom, and we'll get 3/4. So we can say, well, the rate is $3 per 4 miles. But actually, what we usually want is we want the miles in terms, or the rate in terms of units, of 1, something per 1. So we want dollars per 1 mile. So to get that, we need to divide the 4 miles into the dollars to get that, or reduce this down so that the bottom is 1. So we might as well just divide it. 4 into 3. And what we'll get is 0.75, which is, in this case, since we're talking about dollars, it's 75 cents per mile. And that's our rate of change. Number 5. Katniss is filling her drinking bottle. It had 5 ounces in it and is filling at 1 ounce every 10 seconds. Write an equation that models the amount of water Y in the bottle after X seconds. So, this is one of those where we're going to use Y equals mx plus b. We're going to find an equation with Y and X. Okay, Y is the amount of water in the bottle. So, we'll just write our formula here. Y equals mx plus b. So we don't have to, we know what Y is. Y is the water in the bottle, which is changing, and X is the number of seconds. So we need to know what the rate is, m, and what the b is. And the b is the amount that's in the bottle to begin with, the starting point. And we need to know, is it gaining, is it going up? So is it a positive slope, or is it emptying, going down. Well, it says it's filling, so it must be going up. So if you think about it, this is actually quite an easy problem because all the information is given to you. The bottle started out with 5 ounces, so we'll put 5 here. That's our B, our intercept, and it's what it started out with, right? And then our rate is 1 ounce per 10 seconds, so 1 over 10 x. So there's our formula. Y equals 1/10 x plus 5. You might wonder if this equation makes any sense. This is our answer, by the way, this equation. And I just made a little graph here. Here's ounces, here's seconds. The ounces of the Y. That's how much the bottle has in it, and then the seconds, how many minutes passed. So at 0 seconds right here, it's got 5 ounces. At 10 seconds, it's got 1 more ounce, would make it 6. At 20 seconds, see, it gets 1 ounce every 10 seconds. So this actually makes sense. I know my line isn't going to be totally straight here because my graph isn't, perfectly straight. But you can see then up here at 110 ounces, her bottle, if it's a 16-ounce bottle, would be full. It's right about here. And so our line would be something like that. So the bottle is filling. And we could get this equation in another way too. Sometimes they give this problem, they don't tell you the rate of it. They'll say how much water was in it to begin with, or how much water was in the swimming pool, or how much water was in the tub, or how many miles the guy ran, or whatever. And they'll tell you where he started. And but they won't tell you the rate, but they'll give you points. They'll point, so like this one here would be 110 seconds for 16 ounces. That would be 1 point, and this point over here at 30, it would be 30 seconds, because 30, the seconds are our x. 30 seconds at, let's see, 8 ounces. See, so you could use the point slope form for this and find the equation also. Also, you could use the y equals mx plus b form, the slope intercept form, with these 2 points and find it too. It just takes a little bit more calculating, but sometimes that's easier. Number 6, find f of 5. That's from this graph of this function. And so f of 5, the f of x values are the y. They equal the y. So it's where the function is the y value for that function at that point. So if it's f of 5, we've got to find 5. You find 5 on the x-axis. So it's 1, 2, 3, 4, 5. Okay, there's there's 5. F of 5 is the y value. So it'll be right there. So what is the y value right there? Let me mark that. Let me count that again. All right, it's right here. All right, so where are we on the y then? Let's see, there's 1. These are hard to read. 2, 3, 4, 5. Okay, so it's at 5. So the y value at when x is 5 is 5. So that means f of 5 equals 5. Which is pretty easy, right? Number 7, find the domain and range of the function. Okay, so now remember domain is, think of it as a king's domain. We don't like kings, but think of it as a king's domain, which would be like land area, so it would be sideways. So it would be your x values. Your domain is your x values. You got to remember this because this is not going to be on the final. I mean, the definition is not going to be on the final. You have to remember this. And then the range, think of it as the range of a rocket. So range would be, how high is it going? Or if it crashes, I guess, if it crashes in the ocean. So the range is this way, and the domain is the values that go this way. So the x values. So if you look at this function here, it's got arrows on the end. Notice? So it keeps going. It keeps going and going and going. So its domain includes every number. It keeps going and going. And if you're not clear when you have a graph, you can ask me if the domain keeps going. I mean, if it stops, if the graph stops at a point, you can tell because there'll be like a round dot there where it stops. So this one just keeps going and going and going. So it includes all real numbers. That's the domain. Now the range goes up and up and up. You can see that, but it starts at a certain point. Starts right here. So you have to figure out what that is. It looks like 8. Negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's a negative 8. So the range includes negative 8. So we will say that the range is where y is greater or equal to a negative 8. And that's the range. Number 8. The position of a pancake in feet above the stove when flipped by a shanty at the International House of Pancakes can be modeled by this polynomial. F of t equals 15t cubed at plus 5t squared minus t plus 7. You can hear my cat whining in the background. So, the question is, how high is the pancake at t equals 2 seconds? Now this may look like a complicated problem, but actually all this is a plug-in problem. When they give you the formula, I mean, they can say all kinds of stuff about how high something is, or it's falling at certain rates, or it's got shot out of a cannon and it was here and it was there. But if they give you what t is, you just plug it in. Okay, so we're going to plug in 2 here, and I just made this formula up, so I think this pancake is going to be really high. Must be a very high ceiling in this place. Okay, so we've got 15. We plug in the 2 for where the t is everywhere. So here this 2 is to the 3rd power, plus 5 times 2 squared minus 2 plus 7. Okay, so now we just figure it out. 2 to the 3rd, we just use your PEMDAS, do the exponents first. There's no other parentheses. So we've got 15, 2 to the 3rd power is 8, 15 times 8, plus 2 to the 2nd power is 4, we've got 5 times 4, minus 2 plus 7. Then we do our multiplication or division, which is, now we have multiplication. 15 times 8 is 120, plus 20, minus 2 plus 7. Okay, so we have 120, 127 minus 2 is 125 feet. Okay, so I think my formula was not very realistic. Either that or Ashanti has a heck of an arm to put the pancake right through the ceiling and up into the air. But anyway, that's the answer. You just plug in 2 for t. Number 9, I want to wrap this up by doing a few exponent problems. Especially that last horrendous looking one there. I don't know if you can see it, it might be too faint. Okay, so we'll start out with 3x to the 4th over y to the 2nd. All of that is to the 2nd power. Okay, so if you look at this one, there's nothing we can do inside the parentheses. So we have to deal with the exponent outside the parentheses. And that exponent says that everything inside everything inside the parentheses is the base. So it goes to that power. Everything inside there, including the 3, goes to the second power. So if you're not sure what to do with that, I mean, there is a rule you could apply where you're going to square the 3 and you're going to multiply the 2 times the 4, and you're going to multiply the 2 times the 2 on the y. But let's say you don't remember what to do. In that case, what you do is this. Rewrite it. 3x to the 4th over y squared times 3x to the 4th over y squared. See, there we've squared it. One times the other. And now, if you can look at that and you say, well, I know that the 3 times 3 is 9. And you can say, well, x to the 4th and x to the 4th, so there's 4 x's times themselves in the first one and 4 x's times themselves in the second one, so that makes 8 x's times themselves, or x to the 8th power. But if that's not clear to you, then rewrite it again, and rewrite it this way. You go 3x times x. So all those are times each other. And then down at the bottom we have 2 y's. And that's times 3 times x times x times x times x. Because that's what x to the 4th power is, right? And then y times y. Now, it's pretty obvious what to do with this. So, here we've got 3 times 3, that's 9. Now we count our x's. It's 1, 2, 3, 4, 5, 6, 7, 8. So 8 x's times themselves is x to the 8th power. Down below we've got 4 y's times themselves, y to the 4th power. That's our answer. Let's do the next one. We've got something to write with. 2y third power over x to the 5th power, and that's all to the 3rd power. Again, same thing. Notice there's nothing to do inside the parentheses. It all has to do with that exponent outside. The exponent, having an exponent outside the parentheses means that everything inside the parentheses is your base, so that is 3 times. Now you can apply the rule and just say, okay, it's 2 to the 3rd power, that's 8. And then there's, I multiply, if it's on the outside of a parentheses, I'll multiply that 3 times the y, because I've got y to the 3rd, and I've got 3 of them, so it's y to the 9. And then that's over x to the 5th. I've got 3 of those, so 3 times 5 is 15, x to the 15. However, if you don't remember how to do that, then we can just expand it. We factor the whole thing out. We've got 2y to the 3rd over x to the 5th times 2y to the 3rd over x to the 5th times 2y to the 3rd over x to the 5th. Now if you still can't see that you've got 3 of 3 y's, then you can still expand it out again. And then at the bottom we've got 3 of x to the 5th times itself. So there's 15 of them there. We can just add them up. 5 plus 5 plus 5. But if that's not clear to you, then you expand it again. Okay? And we'll go 2 times y times y times y. It doesn't take that long to do. It's worth the trouble. Now we can just add them up. Well, we see we've got 8. 2 times 2 times 2. That's 8. And we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 y's. Y to the 9. And we've got 5, 10, 15 x's. X to the 15. So, Same thing. Now we'll do some negative exponents. We've got y to the negative 12 over y to the fourth. So there is a rule that you can use that says, well, if you're dividing, you subtract them. But you may not remember the rule, but one rule you have to remember is if there's a negative, you can put it on the other side of the fraction bar and make it positive. So that y to the negative 12th we can put in the denominator and make it y to the 12th. Okay, so let's just do that. But we're going to have to, of course, replace it by a 1 as if we've divided it by y to the negative 12. Okay, so we have y to the 4th, and then we have y to the 12th under there. All right, so now, and we have to end up with positive exponents. So they're both going to stay under there. Now, if you can see that, you can have 4 y's, and then you've got 12 of them. Then you just add them together, and you got 1 over y to the 16th. But if that's not clear, you know what we can do. 1, 2, 3, 4 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Stick another one in here. 12. And you can count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we get the same thing. We get 1 over y to the 16th. Okay, let's do x to the negative 9 over x to the 5th. Again, if you remember that subtraction rule, you can do that. But we could just put a 1 up here and go x to the 5th times x to the 9. We can just put that x to the negative 9 on the bottom. If we had a negative on the bottom, we could put that on the top. Maybe we should do that. Okay, so here again, you know what to do. You can expand it and put 5 x's and then 9 x's on the bottom, add them together. Or you can just say, oh, I can see this is x to the 14, 1 over x to the 14. Okay, the last one, the last of the last. So we have x to the negative 2, y to the 5th, z to the negative 3, and that's over y to the negative 3rd, x to the 4th, z to the negative 5th. And that whole thing is to the negative 2. So, this is what I recommend you do first with something monstrous looking like that. First thing you do is we'll deal with the exponent on the outside of the parentheses. If it's a negative, that means we can turn that exponent into a positive if we just flip the whole thing over, make it the reciprocal. So what we're going to do is we're going to just rewrite it, but put the denominator on the top. Let's do a different color. The denominator on the top, and the numerator, we'll put that on the bottom. Okay. So we've got y to the negative 3rd, x to the 4th, z to the negative 5th, over x to the negative 2, y to the 5th, z to the negative 3. And now that whole thing is to a positive exponent, positive 2. All right, now we're going to deal with the stuff on the inside before we multiply, 2 of these things. See, because we've got a lot of like terms. Well, not like terms. They're not like terms. We have a lot of the same variables in the top and the bottom. So we can do a certain amount of canceling out and so forth. The first thing we want to do now with this is we're going to put the negative ones that are in the numerator now into the denominator. We're going to keep our positive 2 exponent. We'll deal with that later. That's on the whole thing. But we're going to take our negative, put it like this. We're going to take our first we'll take our negatives from the top and put them on the bottom. So that y to the negative 3, that's going down here. Now it becomes y to the 3. Okay, that's z to the negative 5. That's going down here too. That's going to become z to the 5th. What remains on top is that x to the 4, because that's positive. We'll leave it there. Now we're going to look at the bottom. Down at the bottom we have x to the negative 2. Yeah, x to the negative 2. Okay, so that one right here, I'm going to stick that on top. You got to keep track of this stuff, I have to admit. Okay, so I'll put, this becomes x to the 2. Oh, I put it in red. Okay, and then my y to the 5th, I'm going to keep on the bottom. Y to the 5th. And then that z to the, z is to the negative 3rd. I didn't make that line long enough. Z to the negative 3rd, we're going to put that on top. Z, now it's z to the 3rd. This isn't hard. It's just, I mean, it's hard. The hard part about this is keeping track of what you've got. Okay, so let me rewrite that mess. Okay, so this can all still be the second power. So I've got x to the 4th, x to the 2nd power, z to the 3rd power, and that's over y to the 3rd power, z to the 5th power, and y to the 5th power. Okay, so now we're going to consolidate the ones we have on top and on the bottom. You're not going to get a problem like this. Don't worry about it. I just wanted you to see this. So we have x to the 4th and we have we have x to the 4th and x to the 2nd power. So 4 x's times themselves, 2 x's times themselves. You add them together, you get 6. X to the 6th. Now, of course, you could expand this out too, but I don't have enough room here, so I'm not going to bother. Okay, so x to the 6th, and then I've got z to the 3rd. I'm going to leave it like that. Now on the bottom, I've got y to the 3rd, and I've got y to the 5th. Well, since I've got y to the 3rd and y to the 5th, I've got 3 y's times themselves times 5 y's times themselves. That's 8 of them. Y to the 8th. And then I've still got my z to the 5th. And then the whole thing is to the 2nd power. Okay, now we're at, I recopied it, x to the 6th, z to the 3rd, over y to the 8th, z to the 5th, and then all that goes to the 2nd power. Let's take care of those 2 z's. See, I've got 3 z's on top and I've got 5 on the bottom. So, let me just show you something. X to the 6th. I'll make my 3 z's. Z times z times z. And then y to the 8th. Whoops, let's put that in. And then times z, 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 z. 1, 2, 3, 4, 5. Okay, let's cancel out 3 of them. 1, 2, 3. You'll notice it leaves no z's on top now. There are 2 z's on the bottom. Well, that's to the 2nd power still. Okay, so what we've got now is we've got x to the 6th, no z's on top. We've got y to the 8th, and we've got z to the 2nd power. There's 2 left, and then the whole thing is still to the 2nd power. See, now we're doing it one little step at a time. It's not as big a deal. Okay, you just have to kind of keep track so you don't lose something in the shuffle. Alright, so now we've got x to the 6th, and we've got over y to the 8th, z to the 2nd, and we can square it. So what we can do is, we'll make 2 of them. X to the 6th. Unless you remember, you can multiply that 2 times all the exponents, which, after you do enough of these, you'll start doing that, because it's just second nature to make life easier for yourself. So I'm going to make, when you can do it legitimately, y to the 8th, z to the 2nd. Okay, and you can hear my crying cat again. Okay, so now we have 2 x's. We have 6 x's on the left and 6 of them on the right. 6 x's times themselves. 6 x's times themselves. So 6 plus 6 is 12. So x to the 12th And down the bottom we've got y to the 8th and y to the 8th. That's 16 of them. And we've got z to the 2nd, z to the 2nd, z to the 4th. And we are done. That's our answer. There's a lot of ways to do this problem. Another way that might be a little simpler, but you'd have to be very comfortable with the rules. What we do is we'll start with at the point where we inverted and changed the outside exponent of the parentheses to a positive 2, and we'll deal with all of the divisions of these exponents. So we'll just put our positive 2 on the outside, and we'll say, okay, we've got y to the negative 3, and we'll say that that is minus 5, because you can subtract the 1 in the denominator. Okay, and then we've got x to the 4th. X to the 4th, I'm running out of room. X to the 4th minus negative 2. And I had to rewrite that because I ran out of room. So we have y to the negative 3 minus 5. We have x to the 4th, which you can see on top there, right here, is minus, but the x is on the bottom, minus a negative 2. And then our z on top is z to the negative 5th, and that's minus a negative 3. Okay, so now we'll solve those. So y to the negative 3 minus 5 is to the negative 8. X to the 4th minus a negative 2 is 4 plus 2 is x to the 6th. And z to the negative 5th minus 3 is z to the negative 2. So it's negative 5 plus a positive 3, negative 2. Okay, and that whole thing is to the 2nd power. So now we can either switch our exponents, our negative exponents, into the denominator now, or we could do it after we multiply by 2. So why don't we do it now? I will stop this. Starting again. You can't tell that I did that, of course. Alright, so our positive one we can still have this to the 2nd power. Okay, positive one is zx, so it has a positive exponent. X to the 6th is on top. And then our y to the 8th, we're going to stick that in the denominator so it can be positive. The z to the negative 2, we'll put that in the denominator. That becomes positive. Alright, so now we'll take our 2 and we can multiply it times the x to the 6th, because we've got 2 of them. You know, this is the whole thing. This whole thing is our base now. So it's 2 of them, one multiplied times the other. So we'll get x to the 12th over, then 2 times 8 is 16, y to the 16th, and then z to the 4th. And if you notice, that's the same answer we got before. Took me a minute to find it. It's right here. I could expand this. You can see it's right there. It's x to the 12 over y to the 16th, z to the 4th. Oh, I didn't do something. Oh no, I circled the wrong. This is this and this. X to the 12th, over y to the 16th, z to the 4th. Yes, I did get the same thing. Yippee. And I'm sure you're all relieved that this is it.